In my course, most of the materials have been taken from the book Digital Image Processing. This is written by Gonzalez and Woods, and most of the material will also be from this book. And there are some slides which are taken from Brian McNamee. So whenever I take slide from some source, so I will announce those, and then you can just check the original material. I will comment about the sources of my materials. Okay. So most important book in image processing is this digital image processing. It is like reference book in the whole world in the field of image processing. This is the basic book in image processing. So I think those who are interested in image processing, this should be with them. You can find it in Peshawar or maybe somewhere here. I'm not sure, but you can find it in Peshawar. Okay. So this is the one of the most important reference book in image processing. So if someone is important in medical imaging or any other field related in this visual area, this is the basic book. Okay. Okay, so now we will start our lecture. I think many of you might have heard this sentence that one picture is worth more than 10,000 words. So it means that if you want to explain someone something, if you have some visual contents, then you can better teach the material. But if you have textual material, then it takes a lot of concentration from your side as well as from audience, and it takes more time. But with visual teaching, you can make your points clear easily, and the audience also can understand the material easily with visual aids. For example, if I have this picture, so I don't need to talk about anything. You can make a story of this picture. There is like with 5-second visual activity, you can make a big story, or there is some story even in the picture. So that is why it is called one picture is worth more than 10,000 words. You can see even a story of 300 or 400 words in this one picture. So okay, this will be our outline in this lecture. This is the introductory lecture, so there will be no technical details. There will be just some motivation. What is digital image? What is image processing? And some history of image processing, and some examples of image processing where we can use image processing, and how this field is important in the real world problems. And then at the end there will be some discussion about the key stages of image processing, like what are the basic components of image processing, how we do research in image processing, or how we study image processing, what are the different components. Okay. So first is digital image. So digital image is actually representation of two-dimensional, the representation of something in the form of 2D plane with some finite set of elements. You will be having some scene from the external environment, and then you will represent this scene on a 2D plane. So this 2D plane is actually a set of finite components. For example, here you have Okay, here you have some scene from external environment, and then here you have some imaging system. This imaging system may be camera or something else, and then you have some image plane and your image acquisition system. It can be camera of any type, and then when this scene is acquired on this image plane, so then you have to digitize. This is a continuous representation of the scene. Then you have to digitize your scene, and this digitization is called an image. So you don't have this complete scene and continuous form, but you take some portion of the original scene and you represent, like, you don't take the whole scene, you have to skip something, and that is the concept of digitization. Like, from continuous area you go to discrete area, so you have to discretize the continuous pattern. Do you understand this?
Yes.
Like, you have this some continuous pattern, and then you take some samples from a continuous line. Okay. Okay, let's say you have this continuous line, and then you take some sample at this point, another sample at this point, another sample at this point, another sample at this point, and you skip these areas. Okay, so this means that you are actually going from a continuous representation to a discrete representation, and that is actually the concept of digitization. So when we talk about pictures, so these pictures are actually a discrete representation of some continuous form. Like, in real world you have scenes made of continuous representation, and then you discretize this continuous representation into discrete points. So an image is actually a two-dimensional representation of a continuous structure. Okay. Now, what is pixel value and image pricing? The next important point is pixel value. So pixel values is actually represents gray level or color or height, or opacity means the what we can it means that, like, how whether you can see behind some object or not. Like, we say that water has more opacity as compared to a stone, because you cannot see through the stone, but you can see through the water. So I think okay, let's say, okay, in this image you have some representation, you have some effect, and that effect is like you have some clouds in front of your screen. So this cloudy nature represent this opacity. Okay. Okay, so now we said that a pixel represent gray levels. Okay, so gray levels is any level between white and black. In this picture we have, like, this is black, this is less black, and at the right this is more white. So there are different levels of this black to white, and there are some images which we call gray images. So gray images mean that there is no color, but these images are actually formed from these different levels of brightness or different levels of blackness. For example, in this image there is no color. This is a black and white image, but this is not the exact black and white image. There are different level of brightness or different level of darkness. So such image is called gray level image or gray image. And then there are different levels of this range. There is different range. Here in this image there are, I think, 8 values, but it depends. You can increase this range, and when you increase the range, then you can get better quality image. These are not color images. These are we cannot call it black and white, because in black and white you have only 2 levels, but in gray level image you have no color, but you have many levels. Okay, now as I said in previous slide, that digitization is actually the discretization or the approximation of a real scene. So in real world environment, you have scenes which are continuous, whose you can represent as in continuous form, but when you take image, so you have to digitize this thing. And you can also have continuous images, because when let's say that I have this tree and I draw the tree on my paper in a continuous form, so that can also be a continuous representation. But usually in image processing we have discrete representation. And when we talk about digitization, so in digitization you have to approximate the real environment. For example, if I have, let's say I have this line and I want to discretize this, so it depends about my resolution. If I take low resolution discretization, so it will be like, let's say, this. Okay, now I have these points, and when I will represent this, so I wouldn't be having this discretized form, but it will be like this thing. Okay, so it is not the actual representation, because here if you see at this moment I wouldn't be having this curve. My curve will not be original. If let's say that I have this type of continuous representation, and if I digitize this, so let's say I have one point here, another point here, and another point here, here and here, then the digital representation of this structure will be like this, this, and here I wouldn't have this sharp curve. So in digitization, when your resolution is more, then you get an image close to the real image. If your resolution is low, then you lose information. Now, if in this case, if I increase my resolution, if I increase my samples, then in my previous digitization, I had taken 5 samples, and let's say I take more samples, so I can have samples like this, this. Okay. So in this image, I will lose only this curve. But if I take more samples, then maybe I will further increase my approximation, and I can get closer to the actual real continuous scene. But then the drawback will be I will be having more samples. So usually in image processing or even in real world problem, you want to minimize your resources, cost of your resources. When you take more samples, then you need more storage. And this is a simple scene, but if you have a complex 2D structure or a scene, then you need more samples. If you want to go closer to the real object, then you need to take more samples and you need more storage. So usually we want to minimize our resources or our storage resources, and then we have to take low resolution images. So this is actually a trade-off. We want to take low resolution images, we want to take less number of samples, and we want to have good quality. So it then depends on the use or in the environment whether we need high resolution images or more sample. If you want to send an image through email, then there you need low resolution image, because if you have high resolution image, then you cannot send that through email, because then there are some restriction. So in that case you have to minimize your resolution. But if you want to take images on your camera and you just want to store it on your PC and you have your there is enough capacity on your hard disk, then you go for good resolution images. Okay, now we will be talking about the common image format. So the most simple image format is black and white, or an image with two gray levels. So then you okay, here you have either black pixel or you have white pixel. So if you have this nature of image, that is called black and white, and usually in technical field or in image processing, we want to bring a complex image to a simple form, and then we usually simplify our representation, and in many cases we represent our images in this very simple form with two level of pixels, a pixel with black value or white value. So if it is white value, then that is considered as the object, and if the pixel value is black, then that is considered as background. And there is a concept in image processing that is called segmentation. So in segmentation, you consider a complex object, you want to separate a specific object from that complex environment, and then what you do, you replace the pixel value other than the object with 0 or with black pixel, and the object of interest is assigned white, or you can call it 1. Okay, then we have another format that is called color image, and in color image, for each pixel you have 3 values. So usually a pixel is represented with 3 values. This is, let's say, red, green and blue. So if you want to represent a pixel as green, then you will assign 0 values to these R and blue and 1 to green. You might have studied this in your graphics class. Okay, so then each pixel take 3 values, and then it depends on the different combinations. You have different combination of your images, pixels, and each pixel is formed from these different combination of red, green and blue. Okay. Yes. Sir. Okay. So, and color images for each pixel. For each pixel, we have these 3 different combinations, and then we have another representation, and that is 4 samples per pixel. So 3 values. I said 4 sample. Yes, 4 sample per pixel. So for each pixel, you have this RGB value, and another value is for opacity. So what can be the suitable word for opacity? Transparent, exactly. So the fourth level is transparency, like how transparent you want to have transparency in your image. For example, in medical imaging, if you have MRI image and you want to see inside the body, so for that you will have to take the surface image as transparent, and this is very interesting area. You take the inner object less transparent as compared to the outer surfaces, and then you can see inside the body. So this is one of the interesting research area, where in visualization you make some outer pixel transparent, so you can still see those areas, but those are actually transparent areas and you can see inside there. So that is usually 3D images, that is three-dimensional images, and 2D images you have just one plane, but in 3D images that is actually a volume. So it is a combination of 2D images. Okay. Okay, now we come to the actual area. Okay, what are the areas where we are interested in image pricing? So the first is improvement in images. You have when you take images, so usually these are not in a good quality image and you want to improve the quality. This is one of the basic exercise in image pricing. You take images and you want to improve the quality, and now the question is that why we have bad images. Okay, so if you take images from moon or sun or from Mars, so there you cannot take good quality images, because if you want to receive images from Mars, then you need some like high bandwidth channel, but that is takes too much time and too much resources. So there they take the automatic machines or robot that take low resolution images, and then they can send to the earth in less time with less resources, and then it is needed that these images should be improved. So that is one use of improvement. Then in medical imaging, usually when we take MR images or CT images, there we can take high resolution images, but the problem is that the patient should be inside the machine for longer time. So we don't want to keep the patient for longer time inside the machine. We take images with low resolution, and then we have to use some software techniques or software algorithm to increase the resolution. So that is like one of the basic application area in image pricing is improvement of the images, or that is also called image enhancement. Image enhancement. Okay, and then there is another area where this image pricing is used, and that is image storage, like how we would like to store our images, and then how we would like to transmit these images. And these are also used like for computer vision, where this whole vision process is done by the computer. In industry, instead of human supervision, you want that computer should do these supervision. So you use image processing for storage, like you want to compress images, and then how to compress these images. You want that the images should be stored in a way that it use less storage. For that you compress images. So the image compression is also an application area of image processing. And then transmission is another most interesting and challenging area. Now, if you look to the web, so the website which has more images, it takes more time for downloading or for data to receive on your computer. But if there is no image, then you can receive the number of bits in less time. So in that case, the research challenge is transmission of image data, because in image data we have more information and we have more storage, and it takes longer to transmit image data. So that is also an interesting area of image processing. And then, as I said, computer vision, where you want to reduce the number of human use, and you want to deploy technology for this vision related task. So that is another area of
Sir, can we apply this process to also to the videos? Like
yes,
video?
exactly. This is an interesting question. Video is actually a series of 2D images. So when you apply some algorithm on image, you can just make another loop. If you have video, so this is video are 3D images. In medical imaging, we call these 3D images. This is actually a series of 2D images. Similarly, a video, this is actually a series of two. Video is actually a combination of images, but there we call image as frame. So video is actually a series of frame, and what is frame? It is actually a 2D image. So if you want to increase the resolution of an image, you might have some algorithm, and you can apply that algorithm on video, because then you just need an outer loop to apply that algorithm on a series of images or frames. So yes,
The same will be the case while transmitting or processing the video, sir.
exactly. Yes. Okay, now there is very interesting discussion about the difference or the boundaries of image processing and computer vision. Computer vision is also somehow related to image processing, but these are in a sense two different subjects. One is computer vision, one is image processing. So there is discussion where image processing ends and computer vision starts. In next slide, we will discuss about these boundaries. We have three levels, and I call this as visual computing, like whether it is image processing, whether it is visualization, whether it is computer vision. This should come in the range of visual computing, because here we don't have textual information, we have visual information. Image processing, virtual reality, computer vision, visualization, in all these areas we don't have textual information, but we have visual information or graphical information. So these should come in the category of visual computing. Okay, so we have in image processing, we have low level processes where the input to an algorithm is image and the output is also image. We do some processing, but the input and output both are images. I said we make the quality better from a low quality image to a high quality image. So we take low quality image, we do something, and we get high quality image. So this is low level computation, where the input and output both are images. Okay. So what are the different processing? What that comes in this low level processing? That is like noise removal. Okay, you have some image and there is something which you don't want to be there. Okay, there is some bad quality image, there are some digitization, discretization, where you don't need those values, and we call those as noise. So you want to remove that noise from an image. So the input is image and the output is image, but the input is bad quality image and the output is good quality image. Okay, image sharpening. Okay, so usually in day-to-day life, we are not very interested in image sharpening, but at a research level, usually the researcher, they want to have clear boundaries of the images. If an image, there are different subjects, so they are more interested to see the boundaries of each object. So in that case, we take the image and we make the boundaries sharp so that the different objects can be identified. Okay, for example, we have this input image. One thing, if I have this image and if the quality is not good, and if I improve the quality of this image, then that is low level processing. Okay, for example, here, okay, in this image, usually like this boundary, now these are actually different objects. This is an artery and this is some area of the heart, but there is like these are just touching each other. So maybe the cardiologist would be interesting to have clear boundary of the heart area and the different arteries. So for this, it is needed either to make the boundaries sharp or to remove one object and just keep another object in the image so that they can get information from the image. Okay, then we have a mid-level processes, and in this mid-level process, the input is image, but the output is not necessarily be an image. It can be some attributes. For example, okay, I have on left side I have an image, and on right side I have just removed the background and I have kept the original objects like the artery, and also if you can see, okay, here in this image, okay, in this image there is only this artery and there is no heart area. So if like the physician or the doctors, if they are interested in the arteries, so there is no heart region, and then they can clearly see what is in the image. And you can, when you look to both the images, so on the left side you don't understand what is this, but at least on the right side there is some clear image. So that is actually the first level of processing, but it can also be a second level of processing, because here you can have some attributes like this is an artery and you can recognize something. On left side maybe the expert recognize something, but the common man doesn't know about the details. But on right side you recognize something, you have some object. So usually segmentation is like identification of some object from multiple objects in an image is called segmentation. Okay, so in this case the output is also an image. Okay, and it can also be some attributes. Okay, now the third level, the input are attributes. The input are attributes and the output are understanding. For example, here I have taken this image. Okay, I have taken this image, and here I have computed radius of this artery. Okay, and on this region I have computed radius. Okay, and if you look, there are some small objects, and here I have computed some radius. Okay, now in this area I have given these attributes to my algorithm, and these attributes are, let's say, radius, like radius at this location, and radius at this location, and radius at this location. Okay, and I provide the information that radius at this location is, let's say, 4 centimeter. Okay, at this location radius is 4.5 centimeter, and at this location radius of an artery is, let's say, 1 millimeter. Okay, now from the anatomy of these images one can understand that if an artery's radius is 4 centimeter, then this can be some big artery, or in specific field they might have some names. And if the artery has some small diameter or radius, then these might be those type of arteries. So in this level, okay, in this level of image processing, we provide attributes, let's say radius, and understanding is classification. Like when I say that in human blood, when some physician is sitting with me, and if I tell him that there is an artery and its radius is 4 centimeter, so he will understand what type of artery this is. I say that there is another artery and radius is, let's say, 1 millimeter, and then he will understand what type of artery that is. So in this high level processing, we have attributes from some images, and we have understanding. Okay, okay, I'll leave that because that will make these things complex. But in image processing we have different level. First we have some images. Okay, then we try to get some information or some attributes from these images, and then on the base of those attributes we identify or we classify images. Okay, for example, if I have let's say images of different humans, and from images I compute the height from these images. Okay, so on the base of height I can classify the different people. I have images of different people, and I compute different attributes from these images, and then I use those attributes for some sort of classification or for some sort of classification. Okay, so first is like low level processing. In low level processing I actually increase the quality of images. I have input images and I do some processing of those input images, and I increase the quality of images or the resolution of images. So in this case input and output, those are both are images. Okay, then in mid level, input are images, the output can be images or these can be some attributes. Okay, if let's say that I have this area and there are something inside this image, and I see that this image is actually its shape is that of rectangle. Okay, then what type of attributes I can extract? I can compute length and height of this image. So I just ignore all the rest of the information, but I focus on these two information. So instead of image, now I have two attributes like length and height, and then maybe this information will make some sort of classification. If I have this image and another is, let's say I have this image, then here I can see that this looks like a circle. Then in circle the most important parameter maybe is radius. Then I discard rest of the information what is inside this image, but I say that I have this image and its shape is like circle, and then I just compute the radius of this image. And here I say that okay, I have this image and it's like rectangle object, and then I discard rest of the information and I only focus on these two information. And in next process I can classify these objects. For example, in industry, if you are manufacturing some item and you have assumed that the item structure is circular or it's rectangular, then you can, instead of human observation or checking this object by human, you can automate the process. You take an image and you want to check whether the shape is circular or not. If the shape is not circular, then it means that there is some problem in the manufacturing process, and then you can identify this problem in this manufacturing. Or if the desired shape is rectangular, then you can mark any object whose shape is not rectangular as not the desired object. So in this high, and that is computer vision. Okay, this last level where you classify objects, you want to understand object. When I say that this object is not rectangular, then it means that my algorithm has understood the shape. So when you want that the algorithm should understand these images, then it comes in the category of computer vision. Okay, for this computer vision you have to perform this previous processing, and that previous processing is like, for computer vision you need good quality images, otherwise your algorithm will not work. So if you have good quality input, you will be having good quality of results or good quality of output. Okay, so for computer vision we need these low level processing, like increasing the quality of images or computing the some parameters. So these two levels, that is image enhancement or increasing quality of the images and computing some parameters from the image, this come in the category of image processing. And image understanding or image recognition, that comes in the category of computer vision. Okay, so in our course in this image processing we will be more interested in these first two levels, like image enhancement and attributes computation or parameterization of an image. So we will be more interested, we will be more focused on these two levels. And then this third level or the high level, that comes in the area of computer vision. So okay, now this is history, and personally I'm not very interested in history. You can go through these slides, like what was the first image which was acquired. So I think you can already see this. One of the first application of digital imaging was in the newspaper industry, and this image was transferred from New York to UK in 1920. So this was not actually digital image processing, because in 1920 there were no computers and there were no digital image processing. But this is like the first image which was used in the industry and which was transferred from New York to UK. I think it took 3 hours of processing, but it was one of the fastest communication at that time. Okay. Then a picture of the moon. Okay, so here we have this picture which was sent to Earth by these different robots at the moon, and it was, I think, 1964. Okay, then in 1970 and onward, imaging was used in the field of medicine, and in 1977 I think this Godfrey took his Nobel Prize for the taking the first CT image. Okay, and today you can see that image processing is used everywhere. It is used for increasing the quality of the image. It is used in the field of medicine. It is used in industry for inspection different objects, and it is used for security purposes, for identification of different objects in different people, and image processing is used in human computer interaction, where the computer recognize humans, and instead of giving password for logging into the computer, you just sit in front of your computer and it understand your face. And in like current research, the computer can understand your movements, or this is not like industry level projects, these are research level projects, but the computer can understand movements of your face structure, your eyes movement, your hand movements, and then you can instruct computer, instead of like providing textual input or voice input, you can enter these visual inputs. Okay, okay, so one of the most common use of digital image processing was in the field of image enhancement or noise reduction. For example, this is one of the medical image. This is like these are rib areas where the actual input image, its quality is not very good, but after some application of image processing algorithm, you get like some good quality image. Okay, this is an industry where you have some image with too much noise, and you deploy some image processing algorithm to remove noise. This is another image from some GIS system where you have very blurry image, and you make the image sharp. That is like image sharpening, which I said earlier. You make the boundaries sharp. Here you have very blurred image where the boundaries are not very clear, but you apply some algorithms and you get sharp images. Okay, now this is another area in the field of meteorology, and here like you can see that okay in this okay, this image is very blurred, but on the right side you have a clear image. Yes, one is now. Okay, one of the most interesting application of image pricing is in the field of medicine, and this is so interesting that even researchers from other areas, they are taking interest in this area to come to the field of medical imaging, because there is a lot of applications of image pricing in the field of medical imaging. So this is a very rich area for research, and many people are taking interest, and this is also like beneficial for humanity. So this is another application of image pricing. And in the GIS system, you might already know about these different navigation systems, and you also like apply image processing in these like geography or fields like these. Okay, now this is an image which is taken at night time. So from this image, like you can understand what are the areas where people are living. If you see some light at night time, then it gives you an idea about the residential area on earth. So like this is like just an idea where you can use image processing. For me, this is not very interesting information that if you have lights and from those lights you can understand, okay, this is an area where some people are living. But maybe for policymakers, okay, these may be interesting information, because otherwise they have to explore the whole area. If you want to see, like where in Malakan there is residential area and where there is non-residential area, so it would be too difficult to explore this whole region. But from a satellite image at night time, you can easily extract this information and know that, okay, this area is residential and this is the area where no one is living. So like one of the use. In industry there is lot of uses. I said earlier in my talk that like for checking and for observation, you can use computer vision. This is not image processing, this is computer vision, but actually the base is image processing. You have to apply image processing techniques for computer vision. Okay, for security purposes, so like platform recognition, this is one of the use. Speed checking, fingerprints, you already know about these, and security through CCTV cameras. And one of the use is enhancement of these images. If you might have seen images taken from a CCTV camera, so the quality is usually very bad. Have you seen such images? How many of you might have seen CCTV images? So
Depends on the use.
yes, this is actually you had asked. These are actually videos, and it needs a lot of space to store these videos, so they keep the resolution low. Okay, so that they can minimize the storage capacity. But with this minimization of storage capacity, then we don't get good quality images, and then we don't recognize who are in these images. So if we apply some techniques for image improvement, we can do a lot with these CCTV low resolution images, and we can get good information from these. Okay, and I already said about human computer interaction, so this is another interesting area of image processing where you make the computer understand human face, human gestures, human movements, and a lot. And this is also used in security, like at airports. If someone detects someone with unusual behavior, then the camera should trace this person among the crowd. There are hundreds of people, but if there is some algorithm where you say that, okay, let's trace this person. So there are two ways. Either some police is tracing this body, what he is doing, where he is going, or you can assign this task to a camera. So this is another application. Okay, I think this much is sufficient for today. Yes? Okay, so stop.
One question.
Yeah?
How can a camera detect an unusual movement in the airport, or if someone is
One
suspicious or
minute.
someone?
1 minute.